Okay, class, now we start sections 8.1 through 8.2 graphs. Reading graphs. We have a picture graph, a graph in which pictures or symbols are used. Example 1. Use the picture graph below to answer the following questions. Okay, now, this is nuclear energy generated by selected countries. Now, we know that this for nuclear energy, it almost looks like a mini silo that has smoke coming out of it, but that equals 50 billion kilowatts. And we can assume that this is half, so that'd be about 25 billion kilowatts. It says approximate the amount of nuclear energy that was generated in Sweden. So we'll look here at Sweden. We have what looks like 1.5. So we could take 50 times 1.5. And we know we will rewrite this as 50 times 15. 5 times 0 is 0. 5 times 5 is 25. We add a 0 here. 1 times 0 is 0, and 1 times 5 is 5. So we add them together. We have 0, 5, and 7. Now we add one digit behind the decimal, so it'll be 75, and we know this is billion. 75 billion kilowatts. Kilowatts per hour. So that is our final answer. Now it said approximate the total nuclear energy generated in Sweden and Germany. Now we have Germany here. We have 1, 2, 3, 4, 5, 6. Now we know it's 6 times 50. So we'll take 50 times 6. This will be Germany, which will give us 300. Now, we already know that Sweden was 75 billion. So we'll take 300 plus 75, which will give us 375 billion kilowatt per hour. Okay, now we scroll down here. Note there are a couple disadvantages to making picture graphs. What are they? Basically, sometimes when you make a picture graph, just like here, we had to assume that this was half. This doesn't look necessarily exactly half. So some people could say it's, a quarter. Some people could say it's 30% or something like that. So basically you won't get an accurate representation of what you're trying to show. So that is the drawback of the picture graphs. Okay, now the circle graphs. And they're actually known as pie charts. A graph where each sector of the graph shows a category and its relative size. It says use the following graph showing the favorite sport for 100 adults to find the ratio of adults preferring golf to total adults. Write the ratio as a fraction in simplest form. Okay, it's 100 adults, and we want to find the ratio of adults preferring golf. So first of all, we will have golf, and then we want that to total adults, which is 100. So we have 8 over 100, and we want to write it in simplest form. Now 8 and 100 both has 4 in common. So that will leave us 2 over 25. Now it says here, use the circle graph shown below, showing the percent of Americans with various numbers of working computers at home. A, determine the percent of Americans that have 3 or more working computers at home. So 3 or more, so that includes 3 and then the 4 or more. So the percent, we will add those percents. We have 6% plus 3%, which will give us 9%. It says using the circle graph, find the number of Americans that have 4 or more working computers at home. Now there are 300 million people in the United States. Now they want us to find an actual number. So we would take the percent of 4 or more, And we would take, now instead of writing 300 million, we could just do 300 times the 3%, which we know is 0.03. Now we can multiply this by 3. This would be 0.009. We had 2 digits behind the decimal, so that's 9. 9.00 we know is 9. And we're dealing with millions, so it's 9 million. Now that is your final answer for B. Now we go to C. It says in a circle graph, the percentages should add up to 100. Now remember, this 9 million here goes with B. Okay. Now it says a bar graph. A graph using rectangular bars to show how large each value is. The bars can be horizontal or vertical. Use the bar graph below to answer the following questions. Now, let's take a look here. It says how many U.S. species are in danger? It says approximate the number of endangered species that are insects. Now we look here. Now we basically have only 2 categories here. Well, actually here's the insects right here. We have insects. Now if we look here, this looks like this is a little bit over 40, but not quite 50, so that looks about 45. So we could write down 45. Now, it says which category shows the fewest endangered species. Which one has the fewest endangered species? It looks like the arachnids. Okay, now, it says here the histogram. A special bar graph where the width of each bar represents a range of numbers called a class interval. The height of each bar corresponds to how many times the number in the class interval occurs, called the class frequency. The bars in the histogram lie side by side with no space between them. It looks almost like a bar graph. However, remember, it represents class intervals here on your x-axis, whereas, let's compare this to the bar graph. Whereas with the bar graph, if you notice, the bar graph represents a singular term here. Even though this is plural, it's still a single term, like it's birds, fishes. It's not fishes to insects for this bar. And then they're not connected like the histogram is. Now it says use the histogram to determine how many students score 80 to 89 on the test. So we go here to 80 to 89, and we go here to the top, and it's 12. Now a line graph, a graph that uses points connected by lines to show how something changes in value, often as time goes by. Example 5, use the temperature graph below to answer the following questions. And we have the average daily temperature for Omaha, Nebraska. During what month is the average daily temperature the lowest? Now we look here. If we look here, if we go right across here, we notice that January has the lowest temperature. So it's January. So now we have B. During what month is the average daily temperature 25 degrees Fahrenheit? So we go here to 25. And if you go across here, the only month that has 25 is December. See, this is slightly above that, but December is directly on the 25. So it's December. Now it says during what months is the average daily temperature greater than 7 degrees Fahrenheit? So we'll go here. Now what you could do is you could just draw this line here straight across. Now this is 70 degrees Fahrenheit. So we're looking for the months that are above this line. Now we have June, we have July, and we also have August. So June, July, and August are summer months. June, July, and also August. Now, scroll down here to B. It says section B, constructing graphs. You will need a ruler, protractor, and bag of M&Ms. Now, we could actually skip over this part here. And let's go down here. I'm going to skip this page as well. Now it says draw a circle graph of the data. We're going to skip that. And basically we'll be doing all of these in class. So these few pages that I'm telling you to skip, we will do in class. So now we go to 8.3, which is 8.3 rectangular coordinate systems and paired data. Okay, now we at 8.3 section A, the Cartesian coordinate plane. Okay, now this line that's going vertical, this is called the y-axis. Everything on this line going up and down is called the y-axis. The line that's going horizontal is called the x-axis. Now typically it's just denoted by just having a y here and an x here. Okay, now this point here where the y-axis and x-axis meet, that is called the origin. Okay, now this graph here is broken up into quadrants. Okay, this is quadrant 1. This is quadrant 2. Now we scroll down here. This is quadrant 3. And finally, this is quadrant 4. Now there are some characteristics to these quadrants. Now first of all, everything is written as an ordered pair. Now, of course, all of you know your alphabet. So in knowing your alphabet, what would come first, X or Y? Of course, we know X comes first. So when we do our ordered pair, I'm going to write it up here. Every ordered pair has an X value first and a Y value second. So now, what I want to talk to you all about is the quadrants here. Now, the quadrants do not hit any of these lines here. It's all in these regions. In quadrant 1, your X value is positive and your Y value is positive. Quadrant 2, your X value is negative and your Y value is positive. Okay, quadrant 3, X is negative and Y is negative. Quadrant 4, X is positive and Y is negative. Now, one thing I want to tell you is this here. Let's start off with the x-axis. Now, with the x-axis, there are only 3 things that can happen with the x-axis. It's either, number 1, it goes to the right. Go to the right. Number 2, it could go to the left. And finally, number 3, it can stay. Now, let me tell you this. And of course, everything is done based upon the origin. So you start at the origin. If you go to the right of the origin on the x-axis, then your x value is positive. Now you may want to write that. If you go to the right of the origin, your x value is positive. If you go to the left of the origin, your x value is negative. Now, if you stay, like you do not move left or right, then your x value is 0. Now, you need to write that somewhere that this involves just your x value. Now, for your y value, there's 3 things that y does. It goes up, down, or stay. And this is based off the origin as well. If you go up on the y-axis from the origin, your y is positive. If you go down from the origin on your y value, your value is negative. And if you stay, then your y value is 0. So when we look here, this lets us know that we're going to go to the right on the x and up on y. Left on the x-axis, y, and then up on the y. Number 3, since both is negative, that means we go left on the x and down on y. And then here, since x is positive, we go right on the x-axis and down on y, which is negative.